Fashion Tech Alliance involves higher educational institutions, small, medium and big enterprises and the research center. This project has been co-founded by the Erasmus Plus program of the European Union and is aimed to facilitate knowledge exchange between partners and to design and pilot learning experiences to engage students in a fashion tech residency program, embedding young talents in the company's innovation activities. A central objective of the project is to design multidisciplinary, interdisciplinary and intersectoral learning activities involving international students from 5 European universities. The contents of the lectures have been specifically created to match the needs of fashion tech learning. They have become open educational resources to allow future engagement between a European-wide fashion and textile HEI community and are available under Creative Commons Sharealike 4.0 with the aim of a wide and free distribution, access, use and reuse. Ready to learn more about fashion tech? Enjoy the lecture!
Measuring of product experience. First, let us introduce ourselves. I am Buso and my colleague Youngjin Chae, and we are working at the Department of Sustainable Design Engineering at the Faculty of Industrial Design Engineering, TU Delft. And today, we are going to give a general introduction, and then I am going to explain what do we mean with product design and user-centered design. And my colleague will then talk about more in general what are smart textiles, how you can define them and distinguish them from wearables. Then she will talk about the concept of wearability to evaluate the product experience of smart clothing and the different types of comfort that you need to test and take into account when designing. So the introduction will be an overview about user-centered design and wearability. These are the two core concepts when designing and measuring the product experience of smart textile products. My colleague will then explain that 3 different dimensions of comfort exist, and we will provide you some practical examples of tools and methods that you can use to evaluate the experience of smart textile products. But first, what is product design? You can pretty design everything. You can design products, services, strategies, even brands. And yes, you can design smart clothing. But let's have a look at the literature, how it is defined. Rosenberg and Akels in 1995 defined design, specifically product design, as the process of conceiving an idea of some artifact or system and translating, expressing this idea into a materialized form. On the right side of this slide, you can see the 3 pillars that are at the basis of design. So design has different meanings and shades, but these 3 principles are always present in every design that you are going to make. And these 3 pillars are people, business, and technology. And you, in the role of the designer, you can choose which pillar to focus on, depending on the project and the personal interest, for instance. And what we suggest during this lecture is that when you design smart textiles, you should take specifically the people's needs, the user's needs into account. And to do so, we're going to talk about user-centered design, also known as UCD. This is an example of a teapot. And if you were to design a teapot just by thinking which technical features are actually needed to make it work, you would think, well, I need this exact shape, I need a handle, a lid to cover it, and a spout. But if you only consider those requirements, then you would pretty much end up with something that could look like the picture on the right, where the spout is misplaced. And yes, it can still work, but you would probably hurt yourself while using the teapot. And this is just a funny example to show that something could go wrong when you don't take the user into account. And the same can be said about more technological devices, such as the computer. In the picture on the left, you can see one of the first digital computers from the 50s. And as you can see, it was a very big machine and only very competent people could actually work with it. the transition from these kind of machines to more to the laptops that we know at the moment not only was allowed to thanks to the developments of technology, electronics, computer science, but also because of a shift in mindset of the people designing such products. Nowadays, we design not only for the function, but we design for accessibility, usability, and we want the products in the end to be as much user-friendly as possible. So let's have a look at how user-centered design works in detail. On the right, you can see the basic design cycle. So it starts with the user research. So you need to understand what is your target, what is your user group, and what is the context of use of the specific user group. After that, you will be able to define the specific requirements and the goals that your final design idea would need to satisfy. And then you can start thinking, ideating, and creating possible solutions. In order to evaluate them, you need to first create a simulation of the final design solution, such as prototype, for instance, and you need to test the overall experience of this prototype, so that you can have already an idea of how the final product could work at the end. And there are two important points to remember when using a UCD approach. The first is that it is an iterative process, meaning that once you've gone through one cycle, it could always happen that you have to go through it again, because you could end up with more questions that you actually had before, and you need to find alternative solutions to problems that came up. Another important point is that you need to take the user into account in each or in most design phases as possible. So, for instance, you can already ask the user feedback at the very initial interview of get-to-know interview. Or you can ask the user participation in creating some concepts. Or in the evaluation phase, then the participants of your test would be specifically users that would end up using your actually final design solution. Specifically, in this lecture, we are going to focus on how you can assess, how you can measure the product experience of your smart textile product. And my colleague is going to introduce you the bigger world of smart textiles.
Hello, so from now on I will be introducing you about smart textiles and smart textile product related to the user experience part that Alice had introduced in the former part of the presentation. So let's begin from the general introduction about what smart textiles are and what are the definition about it. So before using the definition itself, why don't you share the image below the slides where each textile is colored in yellow. And what you can see in those yellow parts is that somehow the textile is interacting either with the person or people. So we go back to the smart textiles and its definition. We can define smart textiles as such. So the intelligent textile structures or fabrics that can sense or react to the environmental or the user stimuli can be the basic definition that we can use for smart textiles. Meaning it's about textiles, but how the textile interact intellectually. So we go to the next page where it shows the different two types or the different two subcategories of smart textiles. So smart textiles can be either defined as active textiles or non-active or electronic textiles. The terms may be used different in a different maybe definition, but the major difference between these two categories of smart textiles are that one is conductive while one is not. So from the title, you can just obviously say which one is conductive. So electronic textiles are the smart textiles using the conductive materials and the electronic sources or the material sources for the intelligence of the textile given to the geometrical structure can be easily integrated for a fine structure object. But in comparison, active textiles, it is under the same category or the same umbrella of smart textiles that reacts to stimuli, but it doesn't necessarily include a conductive part, meaning it's not something working by power or power sources. It's just a simple or a different category of reacting to a different stimuli that doesn't need any electrical parts. So it's pre-programmed. So some of the examples of these active textiles may be textiles based on shape memory alloy or shape memory polymers or phase-changing materials. So using these two different types of smart textiles can be selected or varied based on what type of final usage that you're going to pursue at the end of this product development. So in general, smart textiles is now gaining a lot of attention in research and also in the market aspect. The reason why it is not only because this textiles is truly amazing related to the science and the technological background. That can be one. But the other reason that this smart textile is gaining more attention is the higher acceptance level that it carries to the user. Since we are born with textiles, we are surrounded by it every day, and we have this artifact for more than a few thousand years along with the human history. So this easiness of approach and the concept has made the smart textiles more kind of like in the really passionate these days. So smart textiles and products will be introduced from this slide. So generally speaking, there can be a lot of different product ranges for smart textiles, but we are going to focus more about this product range that is focused more to the user needs or the user interaction, which we can introduce the wearables and the smart clothing in a same sequence. So everyone may know at least one type of wearables, either a smartwatch or a chest band, that a wearables can be defined as an electronic device that can be carried on during the extended period of time in the wearer's daily activity to either monitor the user circumstances or the environmental circumstances in order to provide some type of, let's say, performance or comfort or aesthetical needs. Those kind of functionality would be the users are trying to, the points that the user would like to achieve throughout their daily usage when they are carrying some kind of a wearable device on their body area. But nowadays, not only for the wearables, but there's another category of the second wave or the next generation of wearables. We recently have a better idea about smart textiles or smart clothing and what can be done with it. So smart clothing is basically integrating everything or most of the things that the wearable has done for the last few decades into a smarter or linear textile and clothing geometry that user takes more comfortable about it, where also includes the concept of the user acceptance level gets even higher, and so the designers or the planners or engineers plan to design this smart clothing more in a free movement to communicate more freely with the different type of interaction by using different type of interaction that user takes more naturally or comfortable. So a big comparison between the first generation of wearables or the second generation of wearables, which we just introduced as a smart clothing system, is one is rich and small with the limited interface of wearables, when the other use fully functions the usage of or advantage of smart textiles and make this platform or the interface more usable, approachable, and flexible and light manner. And also it enables to make this platform larger, meaning the user accessibility and the interface gets more easier for the human or the wearer to control during their everyday life usage. So, due to this advantage that the smart textile provide to the smart interface, the application of smart clothing is actually around everywhere. So this slide shows the main three application areas of smart clothing, which is quite broad in general. So first, the biggest application area should be or is the healthcare and wellness providing sector. And second is for the protection or enhancing the performance of the user can be the second application category. And the third, but not the least, would be the fashion or the entertainment part, which also gives an idea of the future communication or the social communication system that the user intends to have in a larger way to communicate with other devices or other people or the surrounding environment just next to you or the user itself. So now we go back to the story about the importance of user experience in smart textiles products. So the reason why we selected smart clothing and wearables as a type of smart textile product was because it's more user-centric. So talking about the user-centric approaches, smart textiles is actually based on a very multidisciplinary approach. So some ideas are borrowed from textiles, while some ideas are borrowed from software to electronics. And in the usability issue, some ideas may be borrowed from smart textile itself, but also by considering the needs from the human side, the user side, and the environmental side, which is the IoT background that we mention every day these days. So we just talked about the user-centered product. So now we are going to go a bit more narrow to the subject of this lecture. We're going to learn about how we're going to measure or how we're going to evaluate the user-centered approach or user-centered design. Is it working well in the wearables or smart clothing or smart textile product? Should be answered from this slide and so on. So before going to the specific answers, we're going to introduce a new term here. Not very new. You can guess what the meaning is by just hearing the term of wearability. So wearability is a wearability. It's actually the room of giving the wearer a comfort to actually control and use the entire system in a very flexible and a comfort manner. So wearability was formally defined as human support of some product. And when some product here is something to do about the intelligent product. But when we try to carry this idea further about the user-centered approach in smart textile products, wearability can be further defined as a user-centered approach to the smart textile products regarding the different condition of the wearer's needs or the environmental situation, and the safety and the usability measurements should be followed to actually finally analyze if we are doing something well about it. So in order to talk about wearability, we are narrowing down a bit more further by using another term of comfort. So what we're going to do here is that we're going to check and analyze the wearability of the smart textile product by using the term of comfort, which is a pleasant state of mind that just it is in the image there. So here we're going to introduce 3 different levels of comfort, which is a thermal moisture comfort and the sensational comfort related to the tactile means. And third, but not the least, about the emotional comfort that should be considered when we are designing a smart textile product, which is user-focused. So now we're going to go to the specifics of how each comfort can be measured to analyze wearability in such products. So the first about the thermal moisture comfort. So the thermal moisture comfort is in a larger category, under the larger category of physiological comfort. So it's actually about how the user feels like thermally and emotionally comfort in a certain environment. Meaning it's something to do about the textile as a medium between the user and the environment without heat feeling so warm or so hot or so cold or so uncomfortable about it. So what we do, we measure the heat and moisture transport by using this medium. And this type of measurement can be either collected by a subjective or an objective manner. So in this part, we provide both examples. So first as a wear trial test and second as a sweating mannequin test. So each have a different type of good points or bad points of how it can be evaluated, but maybe you can guess what the ideas are about. So wear comfort test is actually having the wearer actually wearing the desired clothing or the garment itself, which is combining those kind of e-textile base or intellectual part of about it. So what we do, we provide a controlled environment in the climate chamber and ask the wearer to subjectively and objectively answer about the questions. Well, the subjective matter, but the objectively, we also track the change in maybe the biorhythms like the metabolic rates or regarding the biosignals region that we read by the different type of sensors embedded in the clothing system, or related to the movement that we actually observe during the monitoring stages, which also can give us an idea of how the objective measurements of this the smart garment system. So meaning we can easily compare, or we can also bring to another different analysis of this type by using these two subjective and objective matter collected from the wear trial test. But in comparison, the other type of thermal and moisture measurement can be the sweating mannequin test. There are few different types with different names like Walter and Sam and many others, but it's basically on this similar concept. It's actually placing a mannequin which sweats and also heats, and in the climate chamber with the climate controlled environment, just similar concept to the real trial test. But actually, this kind of situation of having the mannequin instead of the wearer give us or give the researchers or designers more room to test different or extreme condition of the wearer or the user condition. So these kind of in this kind of test, objective measurements is being taken, but we can also consider the different extreme cases where this smart garment will be used at the end, maybe for protection matters, where the temperature, environmental temperature go above the certain level that a human can survive, can be also one of the examples that can be tested here. So based on the different type of product range that you're trying to develop, you can either choose which type of thermal moisture measuring method that you're going to choose for your final product. So, followed by the thermal and moisture comfort. In this phase, for the second phase of the comfort issue for the wearability, we will introduce the tactile comfort, which is another type of a sensational comfort. So basically, tactile comfort refers to the sensational feeling that when what the user or the skin feels when the material or the overlaying material, in case for our topic, smart materials, is actually having contact with the body part or the skin part. So for the tactile comfort, we often use, or when we talk about the comfortness about this tactile comfort of a new material or smart material, we usually refer to the term of fabric hand, where it's actually multidimensional sensation. The meaning is that the textile or the fabric provides, or what the user can feel by actually feeling the surface of the fabric with their hands, throughout their hands. So that's why it's kind of called like fabric hands, or fabric handle can be another word of using it. So this actually gives you a subjective idea of what type or how to analyze the tactile comfort in this given material. But to do this, it's the how we actually measure it is that we mostly introduce a trained handle expert into a test, and then we ask them to actually follow the measuring methods of how that the measurement is provided as an objective from very low to very high, which is related to the final goal or the usage goal of the fabric So meaning when it's like a questionnaire, and then you can actually ask the trained people to actually go over it and then subjectively give their ideas about what these measurements are, giving any type of or their type of a sensational comfort about it. And so this is a subjective measurement of fabric can. In comparison, there's also an objective measurement of fabric cans. And most well-known type is the Kawabata evaluation method, which actually use the instrument to measure the mechanical property or the tactile property of the fabric, and it compares with the user perceptions or the comfort perceptions. So in a regression modeling. So this is another way of doing it. So the good part of having this Kawabata evaluation system compared to the other, let's say, subjective test is that it can do a comparison about the mechanical property and the perception, and see its relationship, how it affects one to another. So these type of both subjective and objective measurement of fabric hands can be further reflected when we are testing the smart materials. When the smart materials have what we have these days, may have these like communication tools by either stripping or tapping some kind of the material surface. In case of ours is a smart textile, to give inputs to the system or to communicate. So these type of communication means of that is brought by different type of tactile motion, the motion of the person tapping on something on a textile surface can be also found how to evaluate it by having understanding the ideas about the tactile comfort described in this page. So the last part of the type of comfort that we should be considering when measuring the wearability of smart textile product would be the emotional comfort. So someone may call it a psychological comfort. So it is an emotional response is subjected to different characteristic of a user and their lifestyle and design and technology or service system. So here we're going to introduce two different type of comfort measurements or the emotional comfort measurements. So the first one would be the comfort rating scales, which in short is CRS system. That is a comfort scaling measurement that is quite often used for such wearables and smart textiles measurement parts. By rating this 6 dimensions of comfort across different dimensions of emotion, attachment, harm, perceived changes and movement and anxiety. And further, it is evaluated and analyzed by using the 20 scale Likert scales. And then, we can finally evaluate what type of emotional comfort may be lacking or should be supported through the type of a product system that will be delivered to the users can be analyzed further. Another way of evaluating the user comfort in such product or product system is a Primo. So Primo is a system actually developed from a group of researchers in TU Delft by representing different type of set of emotions, the 14 sets of emotions in a non-verbal and self-representative manner by different type of emotional showing by the vocal or the face or the gesture and the body movement. So this is another good way, a subjective matter to measure the comfort level of the user in a certain product. And then another way of measuring comfort or the emotional comfort in a product may be combining a user-centric research approach. Firstly, by introducing in a narrative manner about the new service system or the product to the potential users. So in this case, design fiction or the user scenario that is using or interacting with a certain platform or product that the designer or engineer is trying to provide can be actually shown to the possible, let's say, users. And then people or the researcher can observe or interact or ask questions about what they think about it or how they interact about it can be collected through these subjective measurements. So these subjective measurements can be subsequently followed along with or after by showing or exploring the user scenario or the design fiction, either by different means of, let's say, focus group or workshop or observation or interview methods that or any other methods that is taken account as a user research level can be selectively used by considering the final product and how it can be evaluated further for our design output. So this was the last slide of the comfort and what type of comforts they are to measure the wearability of the smart textile products. So in conclusion, after this 30 minutes of lecture, I hope you understand to demonstrate the importance of product and the user-centered approach in product development and why we have identified smart textiles as a type of a user-centric product range that we can also think something different in a different angle. And then the way of how we define wearability and the ideas of how we measure the wearability by the ideas and understandings of comfort and how we can actually do that was demonstrated throughout this lecture, and hope you had a better understanding about it. So after that, finally, the approach that we have made by sharing the case studies or the actual sharing the tools of how to measure it. Okay, thank you for your attention.